All right, good afternoon, everybody. My name is Samir Khan, and I came here today for Friday Forums. First, I'd like to thank John for inviting me out to speak here with you today, and I'd like to thank the Albany College of Pharmacy and Health Sciences for also hosting this event. So, one thing that I want to cover today is the virtual reality of healthcare and exploring virtual reality's role in future of health science. And just a little bit of information for our Twitter and website info is up there. And I just want to talk a little bit about me. I consider myself a multidisciplinary entrepreneur. And I am a virtual reality, augmented reality experience designer. And my professional experience, I am the CEO of SIR VR Technologies Studios by nights and weekends. And by day, I work for the New York State Office of ITS. And previously what I've done is I worked for Orthopedic Incorporated as a clinical affairs consultant and an IT consultant for a pharmaceutical company named Bristol Myers Squibb Company. By education, I went to Drexel University. I did my Biomedical Engineering with a concentration in Neuroengineering. And for my junior design project, I did NO2 delivery by using zeolites. And the senior design project, I did a blood pressure ring sensor device. And that was also usable with Bluetooth and wireless. Much of that you know today as most of these wearables like Fitbit. So that's what it translated into eventually. And then another accomplishment that we had as a team, that's AJ, myself, and some healthcare professionals at the Philadelphia Thomas Jefferson University Independence Jefferson Health Hack 2016. We became finalists in the VR AR track for creating an application, augmented reality application that allowed you to condense and augment information like very dense research papers and get that information in a much quicker and more concise way. A little bit about the studio. SIR stands for Simply Intelligent Response Virtual Reality. And what it does is it delivers an immersive and interactive experience through virtual reality. And what I'm looking to do is to combine that with my background in using brain-computer interfaces and basically marry the two together. So think of like playing Pong and you can control the paddles with your thoughts. So that is something that I'm hoping to go towards and hoping that virtual reality will go towards as it moves forward.
Sorry, I'm not sharing your screen, so.
So one of the things that I asked myself before I even stepped into this, why should I do VR? And I just asked myself really, once I saw this technology is, if I don't get into the VR industry now, would I regret it for the rest of my life? And instantly my answer came back yes. So that's kind of my short story of how I ended up jumping into this right away. So we talked about that. So the agenda for today, I want to talk to you about virtual reality, augmented reality, mixed reality, the roles of developers and game designers, challenges in health science, solving the challenges with VR, and I'm going to kind of segue into my colleagues, Emmanuel Whittington, and he'll give a presentation on effective communication through audio, and then we'll move into VR demos. We'll set up, and everyone can get a chance to try everything out here. What is VR? You visit and immerse yourself in a virtual world. What is AR? And it's basically what you do is you take your real world, you go through a heads-up display, and you add information to it. So you can add a chart or a graph or an assistive tool that you can use as you're doing your daily work. Now, AR doesn't contain positional data. It's just kind of moving along with you wherever your site of vision is. Mixed reality is where it takes the good parts from the VR and the AR and they put it together. So now what you have is, let's say, a model of the heart. And you can place it right here, okay? And then you turn away. You can start messing with a graph of information, let's say, from lab results that you ran earlier. Okay, you go through your lab results, you turn back, you still can refer to that model of the heart. It's still sitting there in that position in space. So that's what mixed reality does for you. In this picture, we're at actually the Games for Change Festival, where there's a lot of information and a lot of exciting opportunities to try out virtual reality technology and up and coming technology that's going to be interfacing with the same In this particular example, we were trying out the Vive headset and doing a demo of what it's like to explore Africa using a virtual reality system, so kind of virtual tourism. So VR, AR, MR technology. So the products that we have out there right now, HTC Vive, Oculus Rift, Samsung Gear VR, PlayStation VR, Google Daydream, Microsoft HoloLens, and MagicLeap mixed reality, which is still experimental and development. By show of hands, have you guys tried virtual reality? Cool, we have one guy in here, awesome. So Games for Change, what we did was try that out, and there was also an experience where we did molecular binding. So like it was a very simple module, but you took molecules or atoms and you put them together to basically put that together. That has huge implications of what you can do further down the road, building complete compounds with it, and kind of doing experimentations without having to rely on limited resources, and basically simulate that out. Another awesome thing that I discovered at my time with Games for Change Festival is OpenBCI. And back in the day, with brain-computer interfaces, so basically BCI's brain-computer interfaces, you would have these very like shower cap-looking headpieces that had like a bunch of electrodes coming out, and it would be like connected to a big system. You couldn't move around. But OpenBCI has completely changed that field. It's completely wireless, and it's 3D printed, so it just kind of sits on top of you. It's very lightweight. You don't even feel that it's there. And it has a very high resolution accuracy. And I was excited to see that technology. They have that out there, and I'm hoping to use that to interface with the Vive to get you interactive experiences where it incorporates thoughts. One of these examples I saw there for using thought control was an interactive experience called parkour. And this team basically took parkour athletes, and they did multiple shots and recordings of them doing parkour. And the way that it would work is you would have this device that's on your head, and depending on how much concentration you had, if you were focused, the person would make the jump. The next video at that point, they would make that actual parkour jump. If you were doubtful, if you were kind of not sure, it would detect that, and the person would actually miss the jump. So it's really cool to see that. So moving on, I'm just going to cover really quick like what the technology is out there. HTC Vive is going to cost you about $800 to get that. Obviously, everything's in development stage, but anyone that's a super enthusiast can get into this. One of the highlights for that is you get a very large play area because of the room scale sensor, and it's very accurate. Oculus Rift, similar, not as much room scale like the Vive does. One of the first launches, and actually the prices got slashed. Now you can get one for about $500. PlayStation VR, you can get one in under $1,000, and it uses the PlayStation Move and the PlayStation Camera to interface with, plus the new headset. Samsung Gear, what's nice about it, it's a mobile headset. You're not stuck in one place, in one area. You can move around. The thing is, you don't know where you're going. There's no boundaries, so you can be walking out in the street and something can happen to you. You don't want that to happen. Google Daydream, similar setup. You get one controller to interact with your environment in there. Microsoft HoloLens. Now this, you can actually see the environment around you. It adds information to it. They're moving more towards mixed reality, and to get into that, it's about $3,000 for a development kit. And finally, one I'm really excited about is MagicLeap mixed reality. This started very hush-hush in Florida. And what happened is that they're making something that would be similar as a wearable. So let's say the glasses you have, it's simple as having these specs. And as you can see in this little animation here, this is on their site. This is the kind of experience that they aim to put there. And what happens with MagicLeap technology is that you'll have light field technology that allows you to have models and other virtual items that will interact with your space. So you can interact with it, it can interact with you. It knows your environment, it knows where the table boundaries are, it knows where, let's say, couches. So let's say you were playing, anyone play Pokemon Go? All right, cool. So Pokemon Go is one of those like phenomenons where that augmented reality really took off. But if you did that with MagicLeap, they would add information like the Pokemon would know where this couch is. So if you try to catch it, what would happen is it would be on the couch because it knows where it is. So that's the kind of technology we're dealing with here. At least that's what they're promising. So we have to still see what they come up with. So now I want to segue into the role of role of developers in game design to what we're, how it can help the health science industry. So what developers do and designers do, we use programming and code to design a solution to a problem, simply put. And game developers make interactive experiences and engage users with and players with challenges and puzzles that they design. This makes learning retention a lot higher than normal. And obviously, a development team can consist of a developer, designer, animator, music producer, and more. Moving on, how they can help is they can create unique solutions for an idea that you may have. You might think, okay, I want to make this idea for doing a chemical lab for combining these types of chemicals, but I don't know how to code. I don't know how to get to this. I don't know how to market the item. I don't know how to bring that into the picture. What developers can do is kind of take that off your hands, and you can partner with small companies such as mine, such as ours, and see what is viable and what kind of solutions you can make a prototype and show you, hey, is this what you're kind of looking for? And so that's in there. And we can partner with healthcare professionals, which is something that I learned from the healthcare hackathons, especially the Independence Jefferson Health Hack that we went to recently. And we can take all that production to the stages of development tools, and a project can typically take from 6 months to about 2 years, depending on the scope and budget that you have. Challenges in health science. This is just basically a study that was done to see how chimps interact with virtual reality. It's pretty interesting. So this guy's trying to grab bananas and then virtual reality. Next. So challenges in health science. What are some challenges we can solve using VR, AR? Here, this is a glimpse from Big Think and how virtual reality will change the face of healthcare. And it was just a slight article about the type of things that healthcare can move into, and those are just bullet points from that article of where we can impact and help using VR, AR. And some of that is mental health disorders, social disorders, learning and training tools, assistive technologies to perform tasks, and patient rehabilitation after major operations. So choosing reality, this is actually another one of those images that I was referring to before about MagicLeap mixed reality. So this is what they promised to kind of deliver later on to the professional health world, where you can be doing the operation, you can actually see an enhanced image of what you're working on in real time. So some solutions to challenges in healthcare using VR, AR. So just to kind of engage you guys, do you guys know what kind of challenges you guys face that maybe VR can help out in, or AR can help out in?
I have a relatively simple one. Whenever you have a new person in a lab, especially a research lab, especially one that's biomedical oriented, their lack of experience typically leads to contamination.
Okay. Yeah.
And that can waste a lot of reagents. So there's really no substitute, though, for the hands-on experience.
Right, right.
So if you could somehow give the hands-on experience to a point where they become comfortable physically working in a lab, and then have them work in a lab to reduce the chances of contamination, that would be useful.
Okay, yeah, I agree totally. So there was a couple articles that showed watching operations as if you held a scalpel. So having them learn from behind someone that's already doing that method. There's also another example where they did relaxing chronic patients with medical VR. And another one was speeding up recovery after a stroke. So these are all, just quick points of some articles that have said what has been used and done so far to solve challenges in VR, AR field. But I'll come back to your point because there's a really cool part after this. So just to wrap up and then just kind of close the loop on how we can solve the challenges is basically bring healthcare professionals and developers together. And hackathons already do that. I don't know if we have one here in Albany College of Pharmacy, but it would be highly recommended if you guys want to start to collaborate and get into that area and bring in tools that can actually help your student body learn more. But there are already applications for those who suffer from PTSD, as well as virtual organ models, like I talked about earlier, and doctors that prepare for delicate procedures. And VR devs can help look for challenges in healthcare professionals, so we can reach out to people that are in the healthcare world and the health science industry and see what they're facing as challenges and see, hey, can we probably design a solution around that? So what has VR done already? So there was virtual reality training that improves operating room performance. And that was an article by Neil Steamer and his buddies. So basically the conclusion for this was that in a lab environment, having this training simulator there, that VR trained residents are 29% faster at gallbladder dissection than non-VR trained residents. And they also found that the VR trained group had a mean error rate that was 6 times less likely to occur in a real operation. So that says a lot. I'm very big believer in practice makes perfect. And when you have limited resources outside of that virtual world, you can't get enough practice because you don't want, like you were saying, you don't want that kind of waste. So to avoid waste, VR can be designed around what your challenges are, and we can simulate it. Now this was done much older technologies. They were doing it in like a Pentium 2, like super old dinosaur computer. Nowadays it's even more powerful, so you can do 30 times better than what has been seen in the results for this. And there was another virtual reality simulator with the VACO and emulsification of cataract surgery and education training. So they came up with a tool that helps basically residents learn how to do that cataract surgery. It takes you through that step by step using a computer-generated simulation based on tomography models. And the goal is to verify and validate the virtual reality surgical simulator to be a reliable tool to be used in medical training programs. So to your point, John, definitely a promising way to do that for the wasting those reagents.
Good.
So I want to segue into Manuel's presentation now. And then after that, any questions you guys have, anything that you can come up with, we can definitely open up the discussion. Thank you.
Give me 1 second to pull my slides. Yes, slide.
We have any questions there so far?
I noticed that in the demonstration of the hands with the elephant, the lighting, so around the hands, the background was real.
Right.
The elephant was artificial, but the lighting on the elephant matched the background.
Okay. It might be just the animation.
Okay.
Because they said that these the examples they give, the recordings, it's not true to how the actual technology works when you see it with your eyes.
Okay.
Because what it does is this glass is a light field technology directly interacts with your eye. And basically, I wouldn't say like laser eye, but similar ways to stimulate the different pathways in your eye so that you're kind of, for lack of a better word, hallucinating what you're seeing in front of you. But that's how that light field technology works. Until they get us a demonstration or a demo unit.
Cool.
That's all I have to show for how it works.
All right. Hello, everyone. Again, thank you, John, for giving us this opportunity to speak to you briefly about some things that we're developing. My job is to talk to you guys about effective communication using directional audio in the pharmacy and health sciences industry. So, first, who am I? My name is Emmanuel Whittington. I'm a Temple grad alumnus. Graduated in 2010 with a bachelor's in broadcasting, telecommunications, and mass media. But I focused on the recording process. And after I graduated, I headed through a graduation party and invited everyone I knew so I can get some money. Right? And I used that to fund my home studio, which I call Soapbox Studio. It's my base of operations where I produce music, I record it, I mix it, edit it, all that great stuff. So I'm also a music producer, guitarist, bassist, drummer, and all those fun things. And funny story, actually, I got into drumming and guitar playing by playing a video game, Rock Band, or actually Guitar Hero 3. A friend of mine brought the game over on the Nintendo Wii, and I thought it was kind of weird because it's a big little baby guitar and has a controller. All right, I'll give it a shot. So I tried it and I liked it, and I got good at it. And by the time Rock Band 1 came out, I liked the camaraderie of being playing with my friends in a band. It was a fake band, but just being a part of a band with my friends was an awesome feeling. And the songs that I owned Rock Band I liked on YouTube, I found them on YouTube, just so I could listen to them later because I didn't have to do it myself. And on the later side, there were videos of real guitar players, one whose name is Paul Gilbert, and that's my guitar hero. Watching him play so skillfully, extremely fast, made it seem so fun, so I was like, all right, I have to get a real guitar now. So I went to Target and I got a little starter kit, and that was about 10 years ago, and I've been loving it ever since. So definitely music plays, or video games play a major role, or can play a major role in you learning not only hand-eye coordination, but how to play a physical instrument. Because I wasn't a drummer until I played Rock Band, so that was awesome. So again, I digress. Let me get into it. So what is directional audio? Directional audio is basically sound emanating from sounds emanating from one position or multiple positions within the audio spectrum. So say for instance, we have your left speaker and your right speaker, and the center represents you. So if you're at a movie theater or something, and you're looking at the screen, ideally, you want to sit right in the middle. So what the audio engineers do is they place sounds or automate certain sounds to be in one position and then move to another position, giving you the idea that something is really happening within the screen. For example, if you're watching a movie and it's the classic bandit or cops and robbers idea, and the band pulls off in the car, you hear the tire screech from one side and goes to the other side. What the engineers do, they make this tire screeching sound start at the right and then automate to the left, and then in sync with the image of the car going from right to left, so that you believe that this is really happening. That's what directional audio is. It's giving you the idea or the illusion that something is physically moving within the sound spectrum. I have a little video that I promise won't be before you too long. So it's only a minute long, and it'll further explain what directional audio does in the sound spectrum. So if you can participate, that'd be great. So basically, give you an idea of what directional audio does for the listener. It gives you a sense of realness that what's happening is really happening. There we go. So why is directional audio important in virtual reality? It not only enhances your overall experience of the player, but it gives you a sense of presence, and it fully immerses the player in the environment of the game or simulation. So for example, if you're in a room and all you have is just a video, that's great, but there's a disconnect because if you see a fan in the corner, but you don't hear a fan in the corner, you don't know that it's there unless you're looking at it. So having the actual sound of a fan sounding in the audio spectrum makes you believe that you're in a real room, that you jump out of this physical world and into another world where there are things happening, things sounding just like in real reality. If you hear a cop car go by, you know the sound because it's somewhere not where you are. It's off the distance somewhere. So having different sounds put in that spectrum makes everything more realistic and gives you a better experience. Don't worry, this is not my personal bank account. I'm not going to share that information with you. I'm just going to give you a personal account of a disconnect that I had when I ventured out to GameCon. I went with these guys down to GameCon in AC sometime in July. Sometime in July. And they had a virtual reality display. So when I went to the event, there was a guy that was demoing one of his games, and it was a alien shooter game. That's cool. I who doesn't want to shoot aliens or zombies or anything like that? So I put the headset on, and I was on a planet. I think it was the moon because the floor was white. I don't really know. But anyway, the headset, the premise of the game was to shoot or survive as long as you could. So shoot all the aliens and spaceships that were coming at you. So that's pretty basic, and you had a health bar. So once your health bar depleted, that was it. The game is over. Whoever got the highest score got some type of reward. So I was trying to go all the way. So when I put the headset on, as long as you look at the aliens, your gun was set to auto fire. So that if you can see the alien, you shoot and kill it. So that's pretty cool. But I noticed I was starting to become frantic because I noticed my health bar was going down. There were no aliens in sight. I'm like, what is going on? So I physically turned around and there was an alien right in my face. Like, no! It made me scream because there was no audio. There was no sound of me getting hit. There was no type of grunts, no type of anything to fully immerse me into the atmosphere. So having directional audio will help your experience and let you know what's going on in the world in a sense. So again, I didn't get the high score because there was no sound. I was kind of mad at the guy. I was like, dude, you need to put some sound effects in here because you're cheating. Like it's not cool. Anyway, that's my story about how directional audio can amplify or really intensify virtual reality. So how can directional audio and virtual reality in the health and science industry, or what can directional audio help virtual reality and health and science industry? They can simulate different monitor sounds in a hospital. Say, for instance, if you were in a classroom and someone's being trained how to do minor operations or things that are more hands-on, having the proper sounds in the proper area will give the student a sense of reality, or a sense that I'm really in the room operating on patients, or having the right sounds or the right heart monitor sounds emanating will give that person a sense that I'm really in a operating room and I'm really working. So it'll give the student a sense of reality that they're really practicing in an operation room because of the sounds that are happening that are usually associated with real sounds that happen in an operation room. Even in chemistry class, experimenting with virtual chemicals, like you alluded to being in a lab. That's also not starting to give me a thumbs up because you're kind of giving my presentation for me. Experimenting with chemicals in a virtual sense is a lot safer than experimenting with them in reality. Because, say for instance, if you make an unsafe decision or if you make a bad concoction, then you don't have to worry about a real explosion or a real hazardous gas forming in your face to have to leave the room, take a shower, and all that stuff. It'll be virtual. So
you could have that be part of the experience. without the danger.
But ideally, you want to be as safe as possible. So having, grabbing flasks and having the clinking of the glass and, all those little nuances that make it more realistic will help the student better concentrate on what's really being done. You don't want just to have a picture and no sound. It's almost like we're watching a soundless picture. What is it called? Motion, just a motion picture. Yes, sound. Yes, thank you. Even an example of a professional trainer coaching you to do certain types of exercises. Hearing his voice come closer or come farther away to the left or to the right speaker will give you a sense of presence that you're really exercising, and this virtual guy is really in the room with me trying to push me to get a great workout. Even sounds of nature walking on a treadmill, which is not ideally a good idea. because people with a virtual headset working on a physical treadmill, it's good as long as you got your hands on the bars. But if you want to go venture off the wall somewhere, you might fall off. So that's not really a good idea. So good to have you guys enjoy it.
They made like the three-dimensional treadmills for VR actually, so that you can actually walk in that.
All right, there you go. Problem solved. In the pharmacy industry, before I jumped on board with Samir, before I knew him, I used to work at Rite Aid, and sometimes they would put me in the pharmacy just to register. I was cashier, and I would pick up the patient's prescription, ring it up, and all that good stuff. But what directional audio can do in the pharmacy industry is practice or have, like I was talking about earlier, the little nuances of the sounds, the scraping of the plastic, or when you're counting the pills, and little things like that, and getting information from a virtual pharmacist telling you to fill out certain prescriptions, so grabbing bottles that have certain medicine in it, counting it out, and giving you the tools you need to prep or to train to do it in the real world. Makes a huge difference. Even consulting patients with various symptoms who also have different personalities. So being able to interact with people who don't have the super happy, chipper personality all the time, but there are some patients who are impatient and want their medicine when they want it, how they want it, they don't want everything from you. So being able to speak with that type of person with that attitude will better prepare you for the real world.
So kind of like a retail pharmacy simulator.
Yeah.
Have like different scenarios to try out.
Exactly. Those are some examples of what directional audio can do. Having a virtual pharmacist on your right side, you look over and then he's there and while your prescription, he's still yelling stuff at you and you're still working. So it gives you that sense of reality and a little bit of pressure to perform well. So to sum it all up, directional audio is just as important as having a visual aspect in virtual reality. Having the right sound on the right item can give you a sense of presence and a sense of reality so that you can stay focused and accomplish your goal. Because you don't want, say for instance, if you're in the operating room or if you're in the pharmacy, you're in the operating room and you see in a heart rate monitor what you hear like a crazy guitar riff. Like that doesn't make sense. There's a disconnect. So having the right blooper bleep will definitely enhance your overall experience. That's my main point. I can't stress enough that. In addition to having virtual reality, having directional audio can make your experience twice as awesome. No one wants to go see silent films anymore. They need to hear the explosions in the cars and gunfire and all that stuff. So that's pretty much my any questions? Comments, concerns?
Discussions? Anything that you have on Skype? Anyone back?
I did have a question for you. Could you define what OpenBCI is?
OpenBCI is a company or basically a tool, and BCI is a brain-computer interface.
Okay.
What they did is they made if you look up OpenBCI, that brings up their website, and it will explain to you how they developed that technology. I think it uses certain circuit technology to take the measurements of your brain waves, certain brain waves, in a couple of different channels, 16 channel and 32 channel types, and then broadcast it over Bluetooth onto your computer interface or receiving unit.
Thank you.
Yep. Anything else on there for me?
Do you see that there's any potential for VR to reduce the use of animals in medical education and research, or is that going to be beyond the capabilities at this point?
Absolutely. There's definitely simulations that you can do that can drastically reduce that. Obviously, you also need some validations, probably from human volunteers that will come into that study and verify that it's safe for humans, which is much more effective. Why try to figure out, okay, mouse does not equal human, so it's not a one-to-one thing there. So with a combination of using a VR, AR simulation of taking that interaction, figuring out the different dynamics for it, the different equations that fall into it, and then using a powerful system like most of those that we have today to integrate that back into an actual virtual reality simulation. And that will give you what you want. Yes?
So during the things like the gallbladder surgery how do you integrate the sensory component? You know, you're clipping something and feeling that clip at the right pressure, things like that.
So I understand that is one of the concerns, because this was an older study before we had a.
But even with like the chemistry lab, you know, there's a lot of dexterity issues that you would want to.
Right. So you're talking about dexterity and one-to-one emulation there. So some of them, like I said, with the room scale VR, it's very on point of where you touch. There does need to be some improvements, but for the most part, it is to get your skills down enough to know that this is what I do next, and get into that repetition space, and just to verify. So far with that, the cataract surgery simulator, they only designed the tool. Their next test was to get that study going between people that took that training versus people who didn't take that training, similar to that previous study which actually had that, and they did that for the gallbladder surgery, like you said.
I think what she's getting at is not so much the spatial temporal location, but more the feeling, the physical feeling.
They made some gloves. It's kind of bulky, but you can actually feel what's going on in the virtual environment. That hasn't been incorporated in this yet, because back then they didn't have that glove yet. So if you really need to feel that out, if it's important for you to know what it feels like, which I would imagine, because you get some kind of pressure release as you're going through the threshold, especially for an eye, you need to kind of feel that out. You can't just jab it in someone's eye. It's pretty much done. So yeah, I understand, and that is definitely a concern that will be resolved with more fine-tuning and more research.
I thought another application while you were talking, it's not the fine tactile things that were applied in that question, but so I have a friend who in Japan who she works at a hospital.
Right.
And she was telling me at a conference recently that one of the most expensive things they do is they do kind of standardized patients in the emergency room. So kind of fake patients. And they really do it for real. I mean, it's like they set it up like it really would be, and they pay somebody to be the patient, and they got the ambulance come, and it's a whole big thing that they do, and they have like actual doctors and nurses and whoever else might be around there doing this work.
Right.
And one of the things she impressed upon me that I just never thought about before is a big part of being good in the kind of emergency room is where to be, where to stand, how things get passed, where equipment goes, when you need to move equipment.
Right.
It's like a whole choreography of it.
Yeah.
The way she described it, it was like they do this big setup, they do this whole thing for one student participate, and then it's like break, set it all up again. She said it's just like intensely expensive, but they want them to have that training.
Yeah.
It struck me that this technology could be a good way to get some of that basic where to be, where to stand, what it's like, how equipment is moved around, and the thing.
Right.
So I just want to sort of throw that out. And it might be expensive to get this technology off the ground, but it sounds like not nearly as expensive as this thing is just to do it in IRL, as it were.
Right, yeah. I mean, some of these headsets are like I said, if you have, the positioning definitely helps out with room scale VR. You'll get a chance to kind of feel that out later when I demo this. And $800 a kit, and getting that out there. Obviously, they can work with you to modify it to have something much better. And right now, it's kind of wired, but what we're looking for is once it becomes wireless, that busy environment will be much more easily navigatable for that student. And that's definitely an awesome application of it. And I think it's a very, very real possibility for sure. Thanks for sharing.
I have a few questions from Skype.
Sure.
One is, what are some of the biggest challenges the industry is trying to solve for VR and DA?
VR and DA, directional audio.
Directional audio.
So I think as far as challenges go, it is, right now they can only give you like small experiences because people can only handle it in so much at a time. But in terms of DA, directional audio, I think I'll hand that over to Emmanuel. What do you think is a big challenge in it's snowing outside?
Yeah. I think one of the challenges in directional audio is the actual speakers or actual monitors that people use. Some people just have a virtual helmet on, and the sound comes from they may have a little speaker on the actual headset. I think if you have actual earbuds, it will be a lot a better experience. It'll give you more sense of presence. But at the same time, you don't want to crash into anything. Well, even in virtual reality, they have the blue balls to prevent
the chaperone grid for HTC Vive. Well, to your point, it comes down to the equipment you're using, the audio equipment. Recently, HTC Vive just released their HD audio pieces so that you can actually get a better directional sound. Previously, they were just using earbuds, and while that works, there are certain particular sounds that you are not going to get the full depth of because of how much sound drivers you have in that piece of equipment. So it all comes down to actually the equipment, and finally, linking it back into VR, where you're having it in that positional space, and verifying that can be time consuming. That's the challenge, is trying to bring down the amount of time that you spend figuring out, okay, this is where the sound is, this is where this is happening, the event, and where can we point that sound going from. So if you point it the wrong way, the user here is not going to hear it. If you point it that way, they're not even standing there, so they don't hear what happened.
How do you account for what the person who's using it is actually doing? I mean, do you just think of all the possible scenarios that...
Right. I think the answer to that is testing, a lot of testing. You get into the situation, you put yourself in it, does it make sense? There are studies out there, for example, you don't want to invoke motion sickness. That was one of the big things. And that's been solved already. A lot of people keep saying, oh, that's going to happen. That's been done by keeping it 90 frames per second using OLED displays. And that interacts the best with your eyes for a virtual reality experience. And then to your point, which is how do you account for all these different scenarios, is open it up to users to try it out, and let them mess it all up and let it come back and then fix it, and then just iterate. Rapid iteration is the biggest.
Another question here. Do you know of any companies who are actively seeking opportunities for collaboration with like a VR?
Any amount of companies are you talking about tech companies, or are you talking about like health science industry, pharmaceutical companies? So it would depend. So if we're talking tech companies, there's plenty of startups that are looking to find any kind of idea.
What about for academia?
Academia?
Yeah.
To partner with them?
Yeah.
I mean, I'm sure if you approach any of them, they'll be open to doing any of those. So like, do I know specifically? I would say that I can probably partner out and reach out to my partners and associates, see what they're looking to do. If the idea aligns with what we're doing, they can reach out to us, and we can see if this is something that we can do for them, and scope out the idea, say like, this is what it's going to take, this is the kind of work that it might take, and what we can do to move it to the next phase and actually move it to a phase of actualizing that idea. Yeah.
This is more of a directional audio question. So, a lot of us have had experience with surround sound, like people get home theaters and stuff. And I was struck by that the first time a friend of mine had it, and I could literally hear footsteps behind me. Yeah, sitting on the couch, and there it is. So maybe this is a technical thing I don't understand, but how do you replicate that with? I mean, headphones are still stereo essentially, right? You have that right sound like you described, but part of it in a lot of your illustrations, it was like depth, it was in front of and behind, like that dimension as well as left and right. Like, how does it? Can it do that, or is it just?
It's more of a combination between the left and right speaker. So, say for instance, there's something that's behind you, and you have your classic left-right stereo. It would probably play it at a very low volume to know that it's not in front of you, because usually any sound in front of you is at the loudest. So when stuff is lower, you usually just turn around and the sound gets louder and it becomes in front of you again. So it's basically a play with the volumes. Yeah.
So it's an illusion. So it's a way of playing with the way you interpret sound. Like quieter means behind.
Yeah.
In some way. But would the ultimate evolution of this be to have some kind of surround system? So the sound source actually is behind, or is that all it needs to be? Like the brain and ears work such that
the brain you'll learn it. You'll learn what those things mean. Just like get used to it, used to playing once you understand how it works. And then you'll be able to find out, oh, that means it's behind me. All right, I should turn around. Why is it getting louder? Maybe it's behind me. That type of thing.
Right. A lot of people work with like that specific area in general. So a company will go in. The nice thing about the Vive is different components and different parts that they can bring in, like different APIs for people to take advantage of when they're developing. So some might focus on the sound component only, and do all that research, figuring out, okay, this is how people hear this here and interact with this, and give you tools that you can use, readily use in order to do that kind of directional sound. And it'll depend on what you want to do with the simulation, or what you want to do with the experience. If you want to do actual physical speakers versus doing the virtual surround sound algorithms. Sound good?
Yep, pretty good.
So I just have a follow-up question to that. So from my understanding from, back when I learned about neurobiology, our interpretation of where something is based on actually just the distance between our two eardrums and how quick. So are your systems and speakers sensitive enough to have that tiny, less than nanosecond difference in sound to account for that, or is it just an imitation of that your brain then adapts to and learns, like you said? I mean, are you actually imitating that, or are you just giving us a simulation that we then adapt to?
It's mostly a simulation that you'll adapt to. I'm sure there are audio engineers who are good enough to have that very small distance, but it's mostly just the latter. Okay. The latter.
Yeah. Right now, I think it requires more specialized equipment for them to use a different set of audio pieces to get that kind of validity or that kind of depth.
It's interesting, the whole idea though, that like your brain will meet the technology, like it wants to make sense, and it will like reach out for it.
Right. It fills in the gaps. It's kind of
It's the same reason why watching football games from the 1980s, now they look so ugly, but back then.
That's true. So, is there any other questions, or do we want to move on to demos?
Oh, let's do some demos. And may I be first?
Okay, sure.
And can you put your contact information on the screen?
Yeah. Did you download any of my slides or no?
Yeah, you have to log back into your.
We can put that table against that wall, and that way they have this whole thing. Yeah, sure.
How mind if I go first?
That would only give you this in front, it could equally well be in front of you. There's difference, right? Or I guess, there would be too many.
I think there's probably never anything that's perfectly in front of you. Or maybe your brain just goes
Well, because you hear the sounds in both ears exactly at the same time.
Then you would think it was in front of you, I guess.
I
can put in.
The
website has the rest of my details.
Right. I'm assuming the people on Skype who hear me will be here for at least another 45 minutes playing with this stuff. So if you want to come down and check it out, you're welcome to.
I don't know. I don't know that much about it.
That makes sense.
I'm just like actually surprised at how much this costs. Like, how it's not, what?
So maybe that's why you don't always know what you're.
I mean, I thought it was gonna be a lot more.
Maybe that's sometimes.
Yeah.
You thought it was going to be more expensive?
More, yeah.
Yeah, the HoloLens for sure, $3,000.
Right.
What they start at.
Yeah.
So don't be fooled by that huge display. It's like in this small kind of area. But it should improve. I really look forward to that.
That was just
Like where did that come from? Yeah, maybe. Or just as someone's talking.
I told some of my cell bio students that they want to escape reality.
They took the wrong idea. You good? Thanks, Eva.
Going back to what you were saying about like my students, they have to, before they go on their clinical experience, like I have to teach them procedure, because they go on procedures to do media, so they make smears and read them on site and talk to the doctor. And it's hard to do that without being
it has to be opposite angled
And I would
first.
say it's even more critical for
This is backwards.
clinical lab sciences. It's far more critical because you make a mistake in the research lab, okay, you start over, you make a mistake in clinical lab, it's dead.
To give my students experience before they get to clinical rotation.
Instead of posing, you just
They're
rephrase it. I
so
was like, oh,
nervous
yeah.
when they go into clinical rotation, they're like, I'm gonna screw, and they haven't, they're comfortable sitting in front of me, but when they have a doctor staring at them, they're diagnosed, like, what's going on, it's like.
You can have an angry individual in a virtual reality world.
Yeah. They're just like, oh, General, you're fine, you're not
Are you
terrible.
going to try this out too?
At least want to watch.
Just open our eyes.
Just the first one, the doctor had a med student come in, and the doctor asked med student to use the Doppler to basically describe it, because med students don't have to
Be able to see what
and just struggle.
Yes.
And the doctor turned his
So
back.
is there any way we could set
Like a piece
that
of
monitor
metal,
up
let the
to
students try and figure it
this,
out,
or
finally just-
set that station up to this?
In the
So they can see it on the screen?
The sensation of the pressure that
Because
is
it's
needed,
coming in
and what it can't
to
be
HDR
doing
already.
that. So if you're constantly over.
They'll still see it.
And you don't cut the right depth of tissue, because it has to be very hard.
It'll be a lot easier if they see it.
You're trying to say
Right,
like
it would be better
eight
than nothing.
Yeah, so that they can actually see what's happening, because you'll only be able to see on that monitor as of now.
It's gonna be, okay. Why don't we,
Tricky.
That's what happens, it doesn't push the reality.
I think it's actually started.
Back when it first started, even if you just thinking the one, you can't pick up on the subtle differences in the technique. Yeah, so you have,
What do you say?
because you think you're being successful, and it's not good enough to tell you you're not, and then you go out and realize there's no subject work. Because you're learning a muscle memory that doesn't have that level of it has to be pretty crude things you have to do with
All that is in fact the tactile sensing regardless for in the future. It's not surprising that part of us.
Yeah.
You know, and that's just like, oh, very,
Well,
way
see,
of
it's the opposite, and I did university.
I don't know.
There are two parts of it. You're a big leap. Because of the Nintendo Wii.
Yes, no, and I did, but it still wasn't.
What's that, like,
Yeah.
there's no tactile sensation, but I found when I use the paddle, like, the little sense. Something my brain is going, that was contact. I don't know if it's a little vibration or something.
Oh, it does have a little vibration, yeah.
Programming should not be a thing. Although, it's better than nothing, probably for a tag on it. We're going to try it for full surgery, it's better than nothing.
Well, I mean, for very specialized things, so it's like a whole system, for very specialized things, it's
No, I think we should be okay. We're plugging in
First
directly
flight team,
into
like,
here.
those giant rockets, and then they would, so they already do have simulators for
Not that it works, it just looks like it's like boss.
whatnot, and they
It's got to add a little bit.
do a,
Some kind of
simulation
flights of
of
stairs and ladders and stuff. Keep it pretty good.
during the work in order to teach the students. But that's when people, for example, you're talking about, there's multiple people involved.
Hey, Samir?
What's up?
Remind me how much these cost again?
Which?
Remind me how much these cost again?
Yeah.
The pods are
You were good.
Yeah.
Yeah, that's why I put the example.
The sensor is cost about
When it's like.
Okay.
break down.
Well, you gotta keep the fear of God in you, right? Make sure you don't mess up.
Maybe they can build in some kind of, some kind of something like, maybe there's something, I don't know, something that makes you feel pressure on it.
So that.
Sound that actually projects.
Can we get this for the context?
Yeah, sure. You didn't want those microscopes.
Yeah, no, let's just go straight to that.
Do you know how do you plug in your laptop? You ever done that?
So, I guess the question you were asking is, that's what where so in the operating environment,
Yeah.
how does it know that somebody needs to get the heck out of my way based on where you're standing?
Right.
It's still for these TVs though.
It's interesting, just how it accounts for everyone's moves and what they're gonna.
No, it's a,
Right, it can't be a matter of just having enough permutations. It's got to actually fit. It's got to think. It's got to figure it out.
I think. So I'm just trying to think of all the different possibilities. You know, it has to have some form of real time thinking ability, I guess. I don't know.
Yeah.
Can we finish with the virtual reality demo?
we're done.
Oh, can I see it?
How you missed it?
See, the problem is this still won't present to them.
Those TVs?
They won't see it because they're through Skype on that. See, if I switch to display it, all of the things are showing on the display, it's not going to broadcast.
Well, that's all I'm.
Oh, yes, very much so.
Because if we had it here, it's one TV. All these people have to huddle around.
There's no connector for it.
No, it's not. Fitness.
They lock in with bolts.
With bolts?
Not
Man.
necessarily.
We need a key from here.
Like no fun allowed.
We need a key from here to get.
Nah, that opens the wall. Or it's a floor.
Possibilities.
Ah!
Cheats.
Hey. Fun allowed.
That's great. There's HDMI.
Sometimes it's better I find it.
Can't see my contact.
Yeah, but even so much.
Yeah.
That's all to cover.
Yeah, and it's just. Somebody moving over their shoulder going, hey, what do you see?
Video classroom because it is very clear to me.
The capture card. The capture card? Oh, line boxes.
clear, well, that's Bob. We should take it out of the personality.